Uh, Good evening. This is October 9, 8 p.m. Eastern Time. On this session, we're going to start lab uh, 2. Mostly on the lab 1, we learn about the basics of the uh, SkyNet visual observation for various items like planets, dwarf planets, and galaxies and other deep sky objects, nebulas, and also see how those gonna work. And sometimes when you do the submission, you don't expect to have a good result. Sometimes you needed to redo it again, resubmit, and resubmit is easier. Go to the previous one that was wrong, and I'm gonna show you again that resubmission one more time, and then this today we're gonna go lab 2. Lab 2 mostly starting or measurement of the distance ladder on the astronomy, starting from the Earth. They're gonna see how we're gonna measure the sizes on the Earth, and we go to the Earth parameters. And I sent some videos on the links on the today announcement. Uh, we're gonna look through one of them that is very interesting and also good for the measuring the perimeter of the Earth by Carl Sagan. And also we had provided few uh, basic kind of write-up that I'm gonna share it to you after the today. And John and I, we collected those so far for the various items that is needed for the measurements tool that we're gonna learn on that. Therefore, let me go over the sharing the uh, basics of the item that we're gonna look through it tonight. And just give me a second. And also, we're gonna look through some information about the uh, understanding of the Stellarium. That's one of the key tools on the lab too. We're gonna use it frequently. And let me go over first to the uh, SkyNet. Let's see which one. Okay, here we have on the home on the courses. We're gonna go to the. If you don't see it, the picture that I shared, just let me know. Just bug me and let me know on that. Here, the one before we going to the lab 2S, we have two labs here, lab 2S, lab 2G. Lab 2S based on the Stellarium. Because of that, we call it S. Lab 2G can be done by the Google Earth as well. Same thing as with Stellarium. And the reason that I'm choosing the Stellarium because the Stellarium gonna be helpful on the next item like a Galilean revolution and other labs. It's gonna be helpful as well. Because of that, I use it Stellarium in here. But feel free, you can go and learn about 2S or 2G. It's free in your hand after you pay the $65. Therefore, you can go and learn also to see how we're gonna make measurements on the Earth and season, both by the Stellarium or globe. Therefore, but our focus on the lab through of the OPIS1 that we're gonna work together is 2S, but the 2G is not very different, and but the app is gonna use different. That is the case. And for the lab one more thing I wanna review it, the one that identified on the, for example, let me go to the SkyNet. Here, for example, I look through the Pluto that I take it the picture. As you see it, it's not very clear here. And if you wanna, although you may try it more, but it's gonna be again the same difficulties gonna happen. For review this one, only if you wanna any pictures, it doesn't matter Pluto or Jupiter or any other. When the picture is not very good and it doesn't satisfy the basics that we learn on the OPIS one, you don't need it to go add new observation. You do it resubmit here. As you see it resubmit here, you do the resubmit, and then when you do this, let me go back again. In here, we go to the resubmit, and here, as you see it, this is the previous set of the data that is collected. And you come here on the target. Again, you specify the object that you have. For example, Neptune, I say. I think something is wrong here. Let me see. Shouldn't be like that. Let me go back on my observation, and let me see Saturn. If Saturn looks good for here, but assume that I do, let me see here, and here, submit. Shouldn't go like that. It should goes back to the, okay, it shows the previous one. There. Then, okay, then here we go here, back telescopes, filters, target. I think target is, yeah, Saturn here. Therefore, when you go back, the way that is like now, let me go back. I mistakenly uh, uh, thought that is different. When you do the submit, it goes back to the last uh, page, review page. But the things that you need to do to go to the target. When you go to the target, you see the same thing that you already identified are here. Saturn, whatever your name is choosing. I choose this number for myself. And then the things that you needed to do, you continue the same progress. Then save it and check it to see filter is correct. Filter is B for the Saturn. That's correct. Then go. You don't need it to do anything because already you specified before. And here you can choose the various different telescopes. I choose, for example, prompt 2, 5, and 6. You can choose the others if needed. For example, might be between the time that you submitted and the time that you have it is different. But you can choose in any of them or selective of them. I choose only 3 of them, prompt 5, 6, and Poland, Krakow in Poland. Therefore, I save and continue. Here, always go to the generic. As you see it, the same exposure that I choose it is here. One exposure, 0.3 second, and double check to make sure the filter is B and everything is checking. Always make sure that when you identify this based on the table, always choose here generic 16-inch because that is calibrate based on that. If you go, for example, here in the Poland is going to be similar. On the prompt 5, you see a little bit different. Instead of the 0.3 is 0.34 something. And if you go to the prompt 6, is duration is different. And therefore, each of them, the program adjusted accordingly, SkyNet program. Therefore, only thing that you needed to do to adjust based on the generic 16-inch back illuminated CCD, that is the standard for the table Excel file that I provided earlier. And whatever, if you have 10 telescopes are here listed, each of them may have different duration. And the SkyNet itself programming developed in a way that adjusted accordingly for each telescope. And then when you see everything is good, save and continue, you back to the review. And then when you are confident, then submit it. Therefore, that's the basics of the resubmission. When you go again, I repeat it again, for example, here, do the resubmit and then come to the target, check everything. You don't need it to identify anything else. Save, again, check the filter and save continue. And then telescopes, whatever you're choosing, if you want to choose different on resubmission, choose and save and continue. Otherwise, everything is you provided is going to be similar. For example, on the Uranus is 1 second. If you check here in Poland is 1 second. On prompt 5 is 1.13 and prompt 6 is 7, 8. The program SkyNet programming is automatically considered and save and continue. On the resubmission, everything is fast. You don't have to provide different things, identification for filter telescopes is already there. And then after you confident everything is good, submit again. That's a very brief review of the resubmission, how you're gonna do. And then if you don't have any question, we're gonna go with the lab uh, 2 in our today discussion. Any question?
So it's going off the chat there. Yeah, everything in back in lesson 1 is always a go-to for all the numbers. And this is the kind of stuff which I'll share. There's a Google page I have that has all these exposures. And like I'll post one in here real quick
Very
um,
good.
so that you can get have those handy. And they're nice because anytime you want exposure for any of these objects, it's just a quick look through. So I'll share that out real quick.
Very good. Thank you, John. You wanna add anything before we continue with the lab 2?
I think it's pretty good. Anybody have any questions on you doing okay getting the planets and the exposures and the moons and all that? Are we making good progress? Because I know it's all new. You feel like you're getting kind of familiar with it at all?
Yeah, so I had a quick question about the planets that aren't visible right now. Like I checked like Mars and Venus, like you can't get them for like can't get the pictures for them right now. If they aren't available like until the time of submission, what should we do for those?
And so some planets you're just not going to do, and some moons you won't do. It's just the way it is. And every time we're going to run this, there'll be some planets you just won't be able to do. And I always keep them on the back burner because some of them pop up later, but they may not. And then it might be a thing, you don't lose your SkyNet. So this spring, you want to see what you can't get Mars right now, get in the spring, this won't go away. So it's like I said, this is something which you may do in college, you might do the rest of your life. You might have to do an observation, you got a credit, take a look, see, and check something out, show your friends how it works.
Thank you, John. And also, adding that John's expression that uh, for a specific semester that everybody looking, for example, fall, winter, summer, and spring, many of the objects may not be visible because we are close to the sun, either planets, dwarf planets, galaxies, nebulas. Also, those may not be observable and taking picture. Therefore, it doesn't we have a list that on the WebAssign, many of them, but not all of them is observable. Therefore, it doesn't mean that because you cannot submit it, it doesn't mean that your score goes come and something like that. But you can keep it Skynet alive as long as you log in after that, and if you have a credit, you apply it. For example, on December or January or a spring as well. You can submit it as long as you have a credit on the SkyNet and do it accordingly. Therefore, but during the semester, you can do that either. For example, we go to the lab 5 and 6, and then you come back, you see Mars is visible or Venus is visible. Then you submitted the Venus and Mars as well. Therefore, this is the kind of things that always based on the moving the object on the sky. This is reality that we cannot do anything. Not all of the object that is on the WebAssign and the OPIS curriculum is available, and everybody knows, and Dan knows, and all the assistant teachers they know that either. Thank you for that's a very good question. And let me go share the some of the materials that we're gonna look over. Here, like the lab 1, we have the introduction, background, and procedure. And as I mentioned, we go lab 2, and the basic of the idea is that Stellarium version, and we look through the Stellarium and Earth and season. And based on that, everything is given here. We have in addition of these 3 items, we're gonna learn how to use the Stellarium if you didn't before you didn't use it. In addition of the learning Stellarium, we're gonna use how the length of the day changes on the latitude and season, and how height of the sun in the sky at midday changes with the latitudes and season, and how we can measure the Earth diameter. And equipment that is needed here is again computer, and we don't need it to do any SkyNet observation in here. This picture shows very good how the longitude and latitude is uh, assigned on the Earth like a plan view. And this is a spherical view that you see it. The good thing about a spherical sphere is that if this is completely a sphere, if you go from one direction, one point, any direction you go, you're gonna reach to the same point. If you go along the great circles, this is they call it great circles. Equator is one of the great circles. The great circle definition is the one that is passing through the center of the sphere or center of the uh, Earth. If we're gonna look through another one, I'm gonna share it with you, this one. This is a material that I'm gonna share with you. We prepared, John and I, well, on this activity. And this is basically, it shows the, what to call it, the location of the Earth and the different axes that we're gonna have and how this material is defined. But basically, the one that is we're describing here on the what to call it, the um, Earth consideration. In here, the basic item that we have here, definition of the coordinates. Why we needed coordinate? We're gonna identify which one location versus the other location. For example, we're gonna identify Charlotte, Raleigh, and for example, Greenwich in the England or some other places on the South America, Africa, Asia, or Australia. They are on different locations. Therefore, on the sphere, the problem that we have on the sphere, there is no specific end and starting point or ID that we can start. Also, if we have developed this sphere in say into the plane, we can say it, for example, lower left, we can call it 0 and based on the coordinate and define it coordinate accordingly. But we don't do that. We normally on Earth, as you know, we get started from equator. This is one of the main uh, kind of plane that is considered for the coordinate, and every every point on the Earth that is located on equator is 0. It called it 0 latitude, as you see it here. All of the points that you had here is 0 latitude, and whatever it is on the North Pole and South Pole, we consider 90 degree. And why it is 90 degree? And this is the one that they decided to define on 90 degree because from the top to the bottom 180. And if you go around the circle from one point to the other point, you're gonna have how many degrees? 380. Therefore, that is very easiest definition of the degrees on a sphere. Therefore, from the equator to the North Pole and equator to the South Pole, each of them 90, but the one that is on the south, we consider minus. The one on the north, we consider plus. And also for the longitude, we have the same problem. We have to decide which of this line gonna be 0. And from old days and the many centuries, they decided the basic Greenwich Observatory near to Greenwich in England, considered as a uh, 0 meridian that we have. The one that we have it here, this is equator, is the great cycle that divided the Earth on two equal hemisphere. It's not very equal. It's not circle we're gonna see, but the other lines that is circle but is parallel to the equator, for example, 30 degree, 60 degree, and 90 degree, it's gonna be shorter and smaller. When we reach to the North Pole, how much radius of the equator in here gonna be radius of the Earth, but radius of the similar plane of the parallel to the equator on the North Pole, how much gonna be? If we divide the circles back from the equator to the North Pole, assuming here this is 0, 15 degree, 30 degree, 40 degree, 80 degree, 70 degree, 90 degree. How much the circle of the uh, parallel latitudes on the North Pole gonna be?
0, right?
Radius. 0, yeah, exactly. Here is the radius is the radius of the Earth. Gradually reduce it. By the time that we're reaching North Pole or South Pole, it's gonna be 0. And the question comes, why we don't see it 0 here? Here you see this one this is shows the perimeter of the equator on the Earth, and this is instead of the 0 we have a big line, and that's a problem that we have when you project the sphere on the uh, flat area. And because of that, majority of the countries that is near to the poles, either here and here, it shows larger than actual physical dimensions. As you see it, Greenland here is larger, here Russia and north of the Canada and Alaska larger, and also south uh, pole region is also some to be larger, but this is because of the extension, artificial extension of the projection of the Earth's sphere that is happening. Here, you don't see much area near the North Pole, but you see plenty of the area is showing here. That is because of the mistake or kind of reason that we make it flat surface from the sphere that causing this issue. This is basics of the what we measure the dimension, and we're gonna use this one to coordinates on the sky, because the reason is that, for example, as we show it on this example that on one of the tutorials that we're gonna share with you here, assume Earth is located here, a dog here wants to observe different things on the sky. We assume that all the sky is uh, projected on a very big circle. We call it celestial sphere. And this celestial sphere extension of the uh, Earth surface to the very infinite direction. And based on that, on the north, south, east, and east, we're gonna mimic that as well accordingly. Therefore, we're gonna learn gradually on that. But whatever we learn here is that this basic of this coordinate longitude and latitude gonna be similarly converted and projected on the sky. Here, several things that we have to know. The Stellarium, I'm gonna show you. I'm gonna show you the page that on the Stellarium, first we have to identify the location. And the location Stellarium, we have to identify different cities we can choose. For example, if here on this picture shows Chapel Hill, and you can search it on this um, um, search box here and find out. And not, I want to emphasize that not all the cities available here, on some of the major cities available. Therefore, not all the cities available on the Stellarium that you may found very small cities or rural area may not be observed. For example, Vaxa, if you check Vaxa, I don't think it is available here. But anyway, in here, after you select the object in the Stellarium, it gives you several important information. Here it gives you latitude. For example, Chapel is north 35 degree 54, and longitude. Longitude is, I call it west 79 degree 3 second. Here it shows based on the degree, and also elevation shows how much the elevation Chapel Hill has. This elevation, we don't need it much at the moment, but we need it mostly longitudinal and latitude of each city, and shows that which which country located, and what the time zone is, and some other good things. And after you identify those, you can provide on the task that you have on the identifying the location. Let me go to the Stellarium that you looked at. Do you see Stellarium when I open it right now?
Yes.
Yeah, okay. Here, Stellarium, you see, first when you do it, if you download it or web version, I use the download version. Download version has more options to choose, but normally when you use it, the download version, it is like this. It is cover everything, and you cannot do anything. You cannot do any other activity. All the screen is filled out over here. This is a very trick that you have to know that and is not easily available. You go down the right, left bottom. As you see it here, there is a small triangle, an angle is there, and there is a flashes arrows. You see it here. You click on both of them. One, two. When you click, it becomes small square instead of the flash. Again, click again, do it again. This one. This one, first thing you have to do that, and then you come here. This is using for the full screen or unzoomed portion. When you do that, the screen become smaller and you can access to the toolbar, you can access something else, and you can do many other different things. This is very basic things that you can do it on the lower left by this clicking this row and also using these bars here. Several items here might be different than the one that if using to the web version, but most of them you can treat and find out important. We don't need it all of them, but some of them is very important. For example, in here, if you clicked on this one, it's gonna have planet labels, and here you can identify the deep object. You see the deep object appears, but sometimes it's too much data, might be difficult to find out. And therefore you can either identify items that you needed here. Then here, this is the one that using for different coordinate system. We don't wanna go over right now. And if you wanna, whatever you object you're choosing to become on center, you click this one. And this is night mode. If you are using outside, if you want to have darkness available using, but we don't want to use much often on that. And then another thing is important to consider here is the one that, for example, here, cardinal points. For example, if you click here, you see southeast, south is available. If you click out, it disappears. And here it shows the if you want to see Earth futures, this is very visual view of the horizon. You may have some uh, homes or big trees beside you. You may not see it like that. Then if you want to remove that as well and see like a sky, you do that. And also if you want to see the ground, remove the ground, you do that. You see, when you do this, you only see the sky. Therefore, that's up to you which one you want to choose. This is basic of the all the information that you had. And as you see it here, the dates and the times is moving because it is alive. Right now it's 1932 is although this is based on the universal time that we're gonna go over. And several things is important here. One is the here to look out for the object. Another one here is to identify the location. The first one on the top is for the location. For example, let me try to see if I can find Vaxa. There is no Vaxa, it's happier. And then say Charlotte. Let me see Charlotte. When you say the Charlotte, if you click it, enter it, it disappears. Before clicking, it's going to show up all the options. For example, here the one that is Charlotte, North Carolina is this one. Then click on that. When you click on that, immediately shows you the latitude of the Charlotte and longitude 35 and 80, and that is going to be used. If you want to use Charlottesville, it's going to be different. If you want to choose Charlottetown, it's gonna be different. Different cities on North America or Western Europe, for example, each of them has a different coordinate. You can see it here, and based on that, the only things that you needed this north value and longitude and latitude that you're gonna put on your WebAssign assignment. This is the first task that you're gonna do, and therefore you needed to open the WebAssign, make it zoom out, and then here you can locate location here. And when you do that, for example, I choose the Charlotte and I closed. Therefore, whatever you see on the sky, it's going to be based on the Charlotte. To make sure sometime it is kind of weird is happening here, you're going to double check and make sure that it's still there. Sometimes disappears due to some reason, but if you want to make sure that you do other observation, you can see it like that. Check it, double check several times. And here you see many of these numbers changes. Date is changing, other thing is changing. This is kind of sky alive. It means that right now all the sky is moving, and we're gonna look through many of this information later on the for example, distance of the planet or no. For example, I'm gonna choose here uh, anything on the sky you wanna see. Jupiter, for example, I will say Jupiter. As you see it here, Jupiter 1 and Jupiter 2 and 3 and others is something else. It's related to the probably their moons. And then I click find it. As you see it, where is this Jupiter? Probably down is not seems to be. And if I wanna make it center, bring it on center, it shows under the ground. Therefore, it's not available. Therefore, I try something else. I will try, say, Uranus. Uranus. Oh, Uranus is seems to be up, and I click it on the center. Where is Uranus? It's gonna be. You can bring it on center, and you can zoom it in and bring it in front. Probably it's very close to the moon. Therefore, that's the reason that is showing the. I think. Let me see the sky observation. Where is the Uranus? Uranus. It's probably somewhere here. No, under the moon. Therefore, Uranus is not available. Let me see something else. Um, which one do you guess? Neptune? Neptune also gonna be under the sky, I believe. No, it's up. Oh, here. Saturn is up there. As you see it, it bring it up here on the center because you choose it here to bring it up. And then you can go over closer. You can see it. This is a Triton. And this is another moons of the Neptune is moving. And this is a picture of the Uranus. You can look through it. And when you click on that, you can identify many other objects like information. You can click it and get the data as needed. This is the data of the Neptune planet. Magnitude is 7.69 at the moment. Absolute magnitude is this much. Mean opposition, that's the many different items that is needed. And one of the key items that we're going to use and find out is the distance that we have. Let me close it again. John, you know how we can make it this one close this cycle? I'm not sure about how,
Yeah.
because this doesn't show, doesn't this items, I don't want to see these items. I
You
think,
know, mine's doing the same thing where it's over way too much information over there. If you do go over to the little wrench with the star on it, and the third one on the left up from the corner, you
yeah,
click on that one, you can reduce your information. It is
yeah, very good, yeah.
information, and then I would do default or short, and a lot of that stuff will disappear. So under information, the second tab, and then I do the same thing, all available, switch that to default and or short, so it doesn't show as much. And default is a nice shorter list. It's not as much. And you definitely can customize this too.
Yeah,
But all available is
that's
just taking the whole thing.
exactly. For example, here, if I wanna only see the distance, I click none, and only I identify distance. And here you see the distance of the, let me see if I lost it, Neptune again. Distance, this one is the distance of the, from Sun, is the 229 astronomical union, and the distance on the kilometer and the light time, that how much time it gonna takes from Neptune to Camas. And that's the kind of basic information that you're gonna get it. Therefore, here you can come and instead of the distance, you identify velocity. And then this is the orbital velocity. And if you want to have a size, it gives you size, apparent size. And if you want to have visual and absolute magnitude, you can identify those. And that's a kind of very good way that you can control instead of the if many items are available here, you don't need it. Thank you, John.
Yeah, Stellarium is a very robust program. There's too many features. And another way to get rid of the sidebar is you just zoom in, find a black area of space and click on it. A lot of times it makes all your stuff go away. But I'm always learning new things in here that nice little features.
They have many good features that we don't want to use all of them, but many of them that is related distance and velocity and size, we may use it, and therefore that's going to be helpful if you can train yourself during this lab to work it out to see if you can. But the first activity, just to choose, we're choosing the Chapel Hill, and then look through the latitude and longitude and put on the place here. The second item that we're going to look through is the summer seasoning. Why it is the seasoning happening? As you look through this top-down view of the Earth orbit on the Sun, we have 4 seasons. That's vernal equinox, summer solstice, and fall equinox and winter solstice. It happened along the one time 1 year along, and those are identified a bit differently. For example, as we know, the rotation of the axis of the Earth is inclined compared to the vertical direction is about 23.8 degree, 20, about 23.5, but slightly different. By the question comes that if you see this one, it looks like a circle. This is a kind of incorrect representation. It's actually orbit is kind of more ellipsoidal than the circle. Therefore, the question comes either on the summer and winter, why we feel it on winter cold and on the summer we feel it hot. And we're gonna look through it here as we see it, the object here. As we see it, this sun slightly from the center of the orbit is from the offset from that is not actually on the center. And the question comes why we have on the winter and summer, we have different temperature we experience on the North Pole. Any answer from you guys you may have?
Isn't the Earth like tilted at a slight angle, so certain parts are closer, even would be closer or further away, even if it was a purely circular orbit?
Yeah, therefore I may ask you 2 questions. One question is that on the summer solstice is closer or on the winter solstice? First, we answer this question. Is it the Earth is closer to Sun on the summer solstice, the longest day, or winter solstice?
Oh, I think summer.
Yeah, that's a very trivial thing that most of us thinking, and I think also the same thing. But this is reverse. And the winter, uh, Earth is closer to the sun than the summer. And the question comes, why in the winter we are cooler and we feel cold than the summer? And that comes on the next question that is answering the uh, uh, idea that we have as we see it on this slide. As we see it, let me show you another picture here. And we're gonna go over. Okay, here this picture shows slightly what is happening. On the winter, we are closer, but the problem is that sun on the winter, you don't see it high on the sky. It's lower in the sky. You notice that when in the summer you see the sun above your head, but on this winter it's very close to the horizon, and that's the reason when it is closer to horizon, when the rays of the warm rays of the sun it comes, it it is distributed on more area than the when it is comes with the right angle. It means that when the sun on the sky is high, it creates more energy of the heat on the very concentrated region on the uh, earth. Therefore, the amount of the energy that is distributed is much higher than the one on the winter. And why it is happening? And the reason that is why it is happening because of the this angle. As you see it, let me see here. As you look through here, when you draw a line from the sun to the northern hemisphere, it is an angle hitting to the earth because the earth rotation is an angle compared to the vertical. And but when it is in the summer, when you align a line from here to here, it's almost vertical, very close to the vertical. On different latitudes, it's different. Because of that, it's not the distance is not important and the getting the temperature hotter on the surface of the earth. The importance is that how much on angle the sun hits to the earth's surface. And that's a very crucial things that we're gonna learn and measure how it can be possible. And that's the reason on the fall and the spring equinox is going to be equal angle. Therefore, it shows that we're going to show how it's going to work, and then we're going to do some material testing on this uh, measurement on lab 2, how we can do that. Therefore, the two questions. One is that the Earth is closer to the sun on winter or summer. The answer is closer on the winter. And why on the winter is closer? We get cold, not hot, because the angle that is heating to the earth is more an angle than the on the summer, and that causing the more heat on the northern hemisphere, hotter than the on the winter. And the next question, it comes: is it similar on the northern hemisphere or southern hemisphere? On if you look through you need to look through the geometry here, and on the example you're gonna do the same thing. When you look through the southern hemisphere, if you draw a line from here, it is on angle, but when you draw it here on here, it's more close to the vertical. Therefore means that when we have summer or northern hemisphere, we have a winter on the southern hemisphere because of the angle, and when we have a winter on the northern hemisphere, we have a summer on the southern hemisphere because of the angle of the uh, sun rays on the surface of the earth on the southern part. Therefore, always we are on different phase. And the reason is that, for example, assume we have winter on the northern hemisphere here. Therefore, sun is closer to the earth. Uh, Therefore, one question comes, is that the summer and winter gonna be same um, hot and cold in the northern hemisphere or southern hemisphere, or it gonna be different? My question is that if, for example, in one of the in Charlotte, uh, for example, in the summer, if it is temperature is 95-degree, if it is we find another city on the southern hemisphere on the summer, it's gonna be colder or warmer than the uh, corresponding city on the northern hemisphere. Any guess?
Wouldn't it be the same?
Almost the same, but the thing is that here it comes to the distance. It means that when you have on the winter, on the northern hemisphere winter, the sun is closer. When sun is closer and hitting on the right angle to the earth on the southern hemisphere, normally you feel more hotter on the southern hemisphere than and also colder on the southern hemisphere than the uh, northern hemisphere. The reason is that in addition of the angle, the distance also play a role on the measurement. But it's not like, for example, become on the northern 90, on the southern become 50. Not that big difference, but the difference gonna be very small. It's not big, about sometimes 5 or 10 or several degrees. Okay, the activity that we had, you have to answer the question that we already did, one of them. And the activity that next one that we're gonna do and we're gonna review for this week, how long the day on the Chapel Hill during the summer solstice. And what we should do, we're gonna go to the Stellarium. We take the Chapel Hill on the location, and then we're gonna look through the specific day and time. For example, what's the northern hemisphere solstice gonna happen? Summer. What day is almost roughly? Although it changes, but summer solstice will happen. Which month of the year?
June?
Yeah, June, exactly. Here, if you look through again to this consideration, the winter solstice is gonna happen December 21st, and vernal equinox is gonna happen 21st of the March, and summer 21st of the June, and June 21st of the September gonna be fall equinox. Sometimes it doesn't happen exactly. It's gonna be 20, sometimes 22, and it will varies. But we assume for this example, uh, all of them is 21st. Therefore, on solstice, we're gonna choose the northern hemisphere 21st of the June, and then for the other items that we're gonna look through it, we're gonna use 21st of the September, 21st of the December, and 21st of the October, or to Mars. Therefore, here we're going to go and observe the uh, elevation of the sun on the 21st of the June for the Chapel Hill and record the observation that we see it here. Therefore, we look through it how much elevation the sun is from the horizon and provide the data here. We just provide uh, what time of the day it's going to happen, that solstice, and how much information we're gonna count using the 24-hour clock. We're gonna record how much the time nearest to zero point 0.1 hours gonna be solstice on the Chapel Hill, and we're gonna answer. For example, here is 6.03, and if you're gonna transfer it to hours and minutes, this is one of the key activity that we're gonna do. We're gonna convert this one to the hours to another way on the 24 hours to change the hours and minutes until the moment of the sunset. And therefore, that's another thing that we're going to measure, the moment of the sunset. And it's going to be 20.57, almost 8 p.m., 9 p.m., and calculate length of the day. Length of the day going to be actually distance between the sunset times uh, uh, the make sure the halfway when it is happening on the exact time of the midday on the solstice on the noon time. Therefore, we're gonna look through an observation on the stellarium to see how we can do that. And after we calculate the length of the day, and we just guess the professional Stellarium also calculate the length of the day, and we're gonna put it values, for example, here, and then we calculate how much error we can calculate on the length of the day. This is gonna be activity we're gonna have, but let me go to the Stellarium to see how we can do that. First, we go to the location, or we identify Chapel Hill. Let's see, Chapel Hill, North America, here. Okay, this is the location. And on the example we provide, north and western coordinates. And then for the time, we have to look through the time as well. What time is right now on the observation? We have to look through the time that we have. Let me close this one. The time that we have here, 25:10 October 9. Then we click on here. Let me do it. Time, I think time is we have to go here. Click on the second from the top, and we're gonna go to the 6th of the 21st of the 6th. This is 6. This is 21. Okay, and then we're gonna look through the time wise. On the time also, uh, for the time we're gonna use the something near to the midday. For example, 12 in here. Okay, assume near to the 12, and then we choose the sun. Then object, sun, and then locate the sun, or we have a sun here. Just make it smaller, zoom it out, put this time away. As we see it in here, uh, we go identify the, uh, what they call it, the Earth futures to see how we can have it. But you can zoom it like this one become, but you don't need it to identify any of them. You just go to the information, sorry, in here, and what we needed to identify how much height of the sun from the horizon. That is going to be altitude. Altitude azimuth. This is identify the location of the sun. As you see it always changing. We close this one. And then is again become again. It's information and sun. Okay. And here we play with the numbers here. As you play with this number, you see this is altitude. The second number is altitude. You see how much it's gonna increase. It's gonna increase. 71, 72, then 73, 74, 75, 78, 77, 77, and decrease. 76 decrease. You see here exactly what time it's gonna be maximum. It's gonna be sometimes here. Roughly. You don't need it to be more accurate, but here it shows maximum elevation of the sun on the uh, solstice day. It's going to be 77.2, and you're going to record the timing that you have. When you record the timing, it's going to be time that is sun located on the highest location on midday, actually, between the sunset and sunrise. Therefore, you record this one, and then you can record the sunset as well. Therefore, the activity that you're gonna do, locate the location, then find the time, 6 of this 20 of this year, and find out what the actual date, time of the day it's gonna be sun on highest altitude by identifying the uh, azimuth altitude here, and record about the value that you had azimuth and the time, and you go back to the activity here. In here, you just identify the um, what to call it, the um, uh, based on the observation that you had here. In here, as you see it, since they time view whatever you're gonna do first using the Stellarium, specify month and day, 6 of 21. It means 21st of the June. That change hours and minute until moment the sunrise happen. This is you calculate the sunrise, And then you go and calculate the midday as I show it to you, and you calculate the sunset as well as a kind of activity on here. Therefore, the sunset, you're gonna put it here, and the sunrise here, sunset here, and you divided this together, 20.57 minus 6.3, you're gonna get the total value of the sun. And in addition of that, you calculate how much the height of the sun gonna be from the uh, horizon that we're gonna use it on the next activity. This activity that this week gonna do, we're gonna show you the sunrise and sunset, and based on the information. Let me go do one of them. For example, on the sunset, right now we have a sun. We bring it down. Okay, we don't see it. Okay, see? When is the sunrise? Probably this time. This is gonna be sunrise. And then if we're gonna do the sunset, we're gonna do the same. We're gonna go to the evening time, okay, here. Then hopefully I will remove this kind of features to make it down. Let's see if yeah, it's okay, okay. Okay, closer. Let's see, I show it uh, here, for example, as you see it here.
Need your chainsaw, I think.
Okay, so
Yeah, chainsaw. That tree's in the way.
yeah, it is, which one? Let me see this one. I'm just trying to see how we can remove it. I forgot how we can do the horizon. Let me see. Yeah, this is we can provide azimuth grid and the horizon like that, and it's gonna help us a little bit to show the location. And then when we go further, this is the location that is the zero. As you see it, zero here. This is gonna be elevation zero. This is shows the exact time of the sunset, 2034 this year. And if we go back to the 6 in the morning, we can do the same thing. We just click the, not this one, the azimuth. It shows the zero grid here. And if we go back, here gonna be sun, no, it is 5 here. We go back down here. This is 0. Then we come here. This is gonna be sunrise. This is 6:02, 2 minutes, sunrise. Therefore, based on this, only thing that you need to do, you click on that azimuth grid. Azimuth grid shows the this uh, coordinate that is related to the horizon and the kind of latitude, altitude on the high, how much high from the horizon. This is the horizon is 0 always, and therefore we come back to our example. We put the numbers here and calculate length of the day and how much accuracy. You can check it uh, uh, Stellarium as well in this regard. For example, if you go Stellarium, you just identify what item you needed, and here and the distance. Oh, additional information. Let me make it none. Additional information, solar and lunar position, rising, yeah, rising, transit, and setting. I think this is the information that we needed. And let me go back. And here, when I click here, as you see it here, this Stellarium give you daytime. It's 14 hours, 36 minutes. Therefore, what you do, you come on the information, you choose these options. This one is not important. Only this rising transit and settings. This one shows the daytime, and this one extra we don't need it. Only things that is needed: rising, transit, and setting. It shows you how much the Stellarium calculate 14.36 minutes, and you come back here, calculate whatever you calculate here versus the one Stellarium gives you, and then calculate the error based on the example calculation here. Example is provided here. You don't need it to memorize. Whatever you measured, whatever Stellarium give it to you, divided by Stellarium times 100. That's gonna be error, and that error you're gonna put it based on the percentage, and provide uh, convert to the decimal digits as you need it, for example, for the degrees. And this is example that's provided for you that you can do it. Hopefully by next time you do this activity, and if you can continue the next one on the how the length of the day varies on the longitude, we're gonna go over the remaining activity on the lab too on the next week. And hopefully, as you see it here, everything is done by the Stellarium. We're gonna check many data that is available from here and do the measurement on the Earth and also Earth perimeter at the end. Any question?
So we're at the top of the hour. If there are any questions, do ask. But I thought I'd share real quick before you get out of here, a fun little image took this summer. So this is, we're talking about the north and south hemispheres. This is in Quito, Ecuador. This is Mitad del Mundo, the center of the Earth. So you see the Earth is actually on its side here. And from the top of this building, you can actually look out, and this is on the equator. So the N here does represent northern hemisphere, and this is the southern hemisphere. It's one place in the world where you can take a few steps and walk from the north hemisphere to the south hemisphere and back. And it's they put a marker here. There's even a nice yellow line this lady was touching up, which shows you that and proof that I was actually there. A little scruffy, but I was there
Very
at the
good.
time. You get a chance to go down. It's a neat place to visit. It's not a very long plane flight, but just a little farther south.
Very good. That's things that you can have 1 foot on the northern hemisphere and 1 foot on the southern.
Yes, and I didn't try to spin an egg. You know, say you can stand an egg up down there on the equinox.
That's it. Yeah.
Anyways,
Thank you.
but
Any question, guys?
Regarding this week's lab, it will primarily be conducted in Stellarium, so not many observations, right?
No, no, no. Yeah, yeah. Observation are only on the one. You can continue with whatever observation done and activities if you didn't finish it, because probably some of them waiting. Therefore, although you can do the lab 2 activities, but in parallel, you can do the complete lab 1 as well. Thank you. Any other question?
well,
Hope
thanks
you
everybody.
had
Let us know how your observations go. I'm trying Jupiter again, so we'll see what happens if those do come in.
anybody successful on Jupiter so far? I'm not.
I got like one okay one. So I
One
good.
Jupiter?
submitted it. Yeah.
Very good. How about
Was that-
Saturn? Anybody successful on Saturn?
Good.
I
Very
got
good.
Saturn.
Very good.
You get the moons? You get the rings? The
Yeah, you
rings?
can see the rings.
Nice, nice.
Very good. Very good. Thank you, everyone. And hope you enjoy watching and taking the picture and also activity on the lab too. And we see each other next week. If you
All right.
have a question, just don't worry, send the email or on the group me, and we are here to respond as needed. Have a good one and see you next time.
Okay, good night.